Hello everyone. Having looked at the switches and LAN networks, wireless access point, 802.3 Ethernet and 802.11. We also looked at previously about virtual LANs. So now it's the time to look into routers. Routers are layer 3 devices or network or internet layer devices. They forward data or route data based on IP addresses and not MAC addresses. So let's see how routers uh, behave or operate in a very simplistic two network case. So what we have here is there is a network, LAN network, which has a network address 10.1.1.0/24. So the first 24 bits of the IP address defines network address. So, and the first address with a host bits all 0, it is never assigned to anyone. The entire thing is called as a network address. So this network 10.1.1.0 having this same network address, this is the network. This is the network. And we'll manually configure, we have manually configured the hosts, these two hosts in this network with an IP address from this network. Similarly, we have LAN 2. Here, the network address is 10.1.2.0/24. So what we have done is the first address of this network 10.1.1.0 has been provided to the default gateway or the router to which this network is connected. Why is this called the default gateway? Because for this LAN to connect to any other LAN or any other network, it has to go through this router, particularly this interface of this router. And this interface of this router hence is called a default gateway for this network 10.1.1.0. And we have manually configured with, for example, here simply configure this with the first IP address of this network. The first IP address is 10.1.1.1. As we have already reiterated, 0 cannot be assigned to any hosts or any interface. That is reserved or designated as the network address. Similarly, the last IP address, in this case 10.1.1.255, that means the host bits are all ones, that cannot be assigned to any interface because that is reserved as a broadcast address within that network. Anyhow, so this is the first IP address assigned to this interface of this router. The second IP address, we have given it to this host PC, and the third IP address to this host PC. The other thing we should is if you similarly, sorry, not the other thing. Similarly, this is the network 10.1.2.0. This is a default gateway because for this network to reach any other network, it has to go through this interface of this router. So the first IP address has been provided to this router's this interface 10.1.2.1, and 10.1.2.2 and 10.1.2.3 are given to these two hosts. Now, there is another network. What about this connection, the connection between these two routers? What will happen? They are in a completely different network. So this network, we have assigned it as 10.1.3.0, and we have just configured with this the first IP address, this interface 10.1.3.1, and the last IP address is 10.1.3.254. That is the last IP address, not 255, 254. We have assigned this interface with that IP address. Now we have already discussed a lot regarding switches. So this is a fresh network. So if we try to ping from here to here, MAC address table is empty, ARP cache is empty. Initially ARP will be initiated, and then it will the ARP will be flooded, and so on. But so within the network, what will happen? We know if this PC wants to ping to this PC. What happens if this PC tries to ping here? What would happen? Let's try it. Let's try it. Let's go to simulation mode. And let's do this command prompt. Ping 10.1.1.2. So let's try to ping from here to here. Fine. I think it's 2. Let's say do is, let's say 3 times. Okay, let's do it 3 times. So first, we already know ICMP is generated, but this ICMP process, it does not know the MAC address of the destination. IP address it knows I want to go here from here. The network address is 10.1.1. I am going to a different network, but I don't know what's the IP address. Sorry, MAC address. So ARP is initiated. What does ARP do? This is Ethernet link, so it puts all F, floods it, and then let's see what happens. It is there, it floods it, but it has reached the router. See, it has reached the router at router 0. Now what will the router do? What will the router do? The router will, let's see what happens. The router will respond back. The router does not flood this ARP packet, even though all F is given. That means this ARP packet is asking, this input ARP packet is saying that flood it. But the router does not do so. Why? Because the router only operates on IP addresses. A switch will operate on MAC addresses, but the router operates on IP addresses. It simply responds back with its own. It simply responds back with its own. See what is. Let's see at the router. What happens? What is this destination? The source we know 00. Remember this 00197EB 5C01. So this is the source address of the router. And what is the destination? destination is this A400, fine, 0030 F2C2 A400. So then it responds back. Let's see what happens. The switch will just simply forward the so it reaches there. Then what happens? ICMP generates. So what happened here is the router did not forward the ARP packet any further. What it did is it sent its own MAC address back. Its own MAC address it sent back in the ARP message. So now what will happen is this guy, it was trying to ping this guy, and in its Ethernet frame, when it tries to ping some to another network, to host on another network, it will simply use the interface, sorry, it will simply use the interface destination address of the default gateway. So instead of using the MAC address of this PC, it will use the MAC address of this interface. So let's see next what happens. By this time, host unreachable. Now this is generally most probably because uh, uh, the ICMP message has been generated because it has probably timed out. When you are doing for the first time, pinging for the first time, to get all this information about how to send the data, send this data, this takes lots of time to configure, to find out the routes. Now the second problem here is, let's go forward. So every time we mentioned that there will be, if you recall, we mentioned 3 times. We want to ping 3 times. So in the first time, it got the MAC address of this interface, but it is not able to still go ahead. Why is that? See, so let's stop it here. So why all this ICMP failed? The reason this ICMP failed is, this pinging failed is, the routing, if you see, there is no routing. I will show you. The routing table is empty. Just a minute, I made an error. Anyhow, so you can check this. These are simple commands you can check in Google. Show routing table, show IP route. Okay, this is the command. If you use show IP route command, you should be able to check. So I made an error here. Let's wait till it gets up. But anyhow, Let's check this one then. Show IP route. So here you can see when I type this command on this router, we'll come to this router when it is clearing that bugging problem, when it is cleared. But you see what it has in the routing table, only the interfaces that are directly connected to it. So this network 10.1.2.0 is directly connected, and 10.1.3.0 is directly connected. And this interface 10.1.3.254 is this interface, then 1.2.1 is this interface, nothing else. So this router does not know, for example, if a packet comes from somewhere here, it does not know how to forward the packets. We have neither configured static routing nor dynamic routing here. So that's the first issue. So now we'll come back. If you ping here also, you will find the same thing. Okay, that no routes have been configured statically, and dynamic routing we have not enabled here. So let's now configure some routes and then see what happens. So now another thing is, in this case it worked that we did not set a default gateway. Suppose there were multiple routers connected to this switch, then in that case we should always define a default gateway. Here it did not have any confusion because it will ultimately go to this router alone when you do this ARP and all that. But we should always configure a default gateway. So here configured, see, fast Ethernet, we have done all this. Let's configure a default gateway. You should always do that. 1.1, that is the default gateway for this PC. Similarly for this PC, have I done default gateway? Yeah, PC2 settings, default gateway. Yeah, so this is the default gateway. The default gateway set here. Let's see. Okay, I did probably, but sometimes these things 1.1 is the default gateway. This is the interface 10.1.2.1. Similarly, configure and 1. This is the default gateway. Anyhow, so in this scenario, because there is only one router connected to this network, it will not create an issue, but it's a standard thing. We should always configure default gateway. Now, yes, CLI, it has still not come up for some reason. Anyhow, let's see. So let us now configure a route. Okay, here, let's see. We can do it by command also, but we also have the option here of doing it in the GUI interface. Let's do it from here first. By the time that resolves, I don't know what's the problem. So let's go here. So static. So this router knows this network because it is directly connected. It also knows this network. It is directly connected to this network. What it does not know, this router, is how to reach this network. So we will do like this. 10.1.1.0 What is a network mask? This is a network mask. And to reach this network, where do we have to go? What is the next hop if we have to reach this network from this router? This is the interface that has to be reached. So we'll put it 10.1.3. This interface is 1. If I am not wrong, yes, 0.1. Add it. This is a command. You could do it by command also. Maybe you can use this. Okay. So we have this here. Similarly, this. So yeah, we have finally resolved the issue. Basically, came back to real time and rerun the power cycle. So what I have done is, just like for this router, I have just configured this network, that I have to reach this network. How will I reach? Through this interface. So now let's try this same thing, same experiment. Let's try pinging again. So let's ping. Let's see what happens now. So because I reran the cycle, so again this ARP message. So this ARP cache is lost and so on. So let's try. So ARP generated, it reaches there, it sends back. Because why does it send back? Because it does not, the routers do not flood Ethernet packets. It does not flood based on Ethernet addresses. So, and when it saw, the router saw it is asking for a different network, the ARP is asking for a different network, it simply provides its own MAC address. So now ICMP is regenerated. How is the ICMP regenerated? You can see the destination address is 5C01, which is, you see, 5C01 is this interface MAC address. So ICMP comes here, which is here. Now it is able to do so. Why? Because we have configured a static route, that if you have to reach this network, you have to go to this interface, and this interface, it knows how to reach. Now you can check this, why it knows how to reach. So show IP route. When we did that static route, its table was updated. So here, see, there are many options here in the routing table. Okay, S is for static. You will have all this dynamic, L for local, C for connected. Okay, so generally connected means this network is connected. Okay, L means directly this interface is connected. Anyhow, these are all external routing protocols, internal routing protocols, all these things you can configure. For example, in this case, we'll see how we can use RIP, routing. It is a distance vector routing protocol. It's a dynamic routing protocols. If you recall, there are two types of dynamic routing protocols. One is called link state routing, and other is called distance vector routing. Link state routing is mostly used. Examples are OSPF, Here OSPF or ISIS, and RIP or RIP is a distance vector routing protocol. Generally, OSPF or ISIS those are used, but in small networks, even today, RIP is quite normally, I mean, you will find RIP also being used. So I will show how to use RIP instead of the static route. You can configure RIP instead of this static route. So I will show how to do that. But you can also just get the commands from the internet and try out all this OSPF, ISIS, and IGRP, and so on and so forth. So anyhow, you saw, okay, let's go back. This is what we saw. So for this router, this is directly connected. This interface is local. Then you have 10.1.2020. This network, how is it connected? This is connected via this link in this router. And 10.3.0 is obviously directly connected, and this is the local interface. So this is how you can read this routing table. So let's go ahead. What happens? So most probably now second ICMP packet. Now why did the first ICMP packet did not reach? What happened is timed out. See, when the first ping was happening, they are trying to figure out from where you will, so for example, ARP process has to be initiated. That itself took some time. So because of that, because the route was not, let's say, completely known, so this ICMP packet first ping was dropped. But now the next ping, there is no issue. The other thing is uh, this router. See what happened? This ICMP packet was generated, second ICMP packet, then it reached here. I'll go back, like second ICMP packet, okay? Reached here, reached here, reached here. Now here there is a problem. Now here there is a problem. So it knows, okay, the packet, it wants to reach this destination from this destination. What's the destination address used? See, the source address used now is 00015C02. What is that? What is that? Sorry. See, 00015C02. So the ICMP packet came here. Obviously, it is directly connected to the router. So this became kind of the source address. See, the IP addresses remain same, but in the Ethernet frame, the source and destination, particularly the source address, is changing all the time. Source and destination addresses keeps changing while the packet is being transferred. See, now when it reached here, then this has to be forwarded to this interface. It will go out through this interface of the router, and it will reach here. So if you see in router 1, oh, sorry, where did it go? In router 1, if you see destination addresses CE02. So in this link, and it came from 5C02. in this link. Now, there is a slightly different problem. What is the next destination address? What is the next destination address? It knows it has to forward it through this. But what is the next destination address in the Ethernet ring? It does not know, because it has to get, this PC's destination address. So it initiates ARP once again. Okay, it initiates ARP with FFF. You will find all FFF. What is the source address? Source address is, see, remember, sorry, source address is, remember, what? CE01. Let's see what is CE01. CE01, can you see? Gigabit Ethernet 000, this link. So now, this is ARP packet. It reaches here, switch, floods it. By this time, unfortunately, ICMP again times out. So the next ICMP packet, see, it's timed out. So the next third ICMP packet is now generated. And so it goes on. So now let's make this a little bit more. Okay, what happens is, let's reset the simulation. Okay, and make it real time. Why I want to make it real time is, you see, in simulation mode things go a little bit slower, and this constant delay, we have to change this, I guess. You have to make sure that what is the time traversing from one link to the next. We generally, we cannot make it, at least I cannot do it, uh, what is the appropriate time so that things don't time out. So what I will do now, so go to real time. Okay, stop the simulation, reset simulation, go to real time. So I want once, at least once, this ping to be successful. So ping 10.1.2.2, let's say 3. Okay, so all were lost for whatever reason. Let's try to figure out why all were lost. So this PC, oh, this is the reason. This is the reason that all were lost. So I forgot for some reason to configure the IP address 10.1.2.1. Probably it got lost, or 255.255.0. Probably it got lost. Default gateway is fine. This is 2 and this should be 3. So let's configure 10.1.2.2.3. 55.0. Okay, let's go ahead. Now, even simulation mode, I hope uh, we'll be able to do it. But at least ping. Okay, let's do it 3 times. Goes here, goes here, goes here, goes here. ARP is flooded. This ARP obviously it will not accept. This guy accepts. Response. This router now can use the MAC address of this PC. But by this time, I think this first ICMP is timed out. Yeah, let's see. But this second time, it should be successful, in my opinion. Yes, it is able to ping and it will get a response. So, 2 of them will be successful. So, you can see received 2, 1 lost. So the other thing is you must understand now that just like these computers, we have an ARP cache. Okay, it's reset simulation, real time. Okay, just like all these computers, they have an ARP cache or cache, whatever. Switches have a MAC address table. The routers also need an ARP cache. So I will show you. Why does the routers need an ARP cache? To map MAC addresses with IP addresses. The interface of any router, you can consider it similar to that of a PC. So for example, when the packet reached here and it had to send to this, how should it send it? If there was another link and another network and a packet came here, on which link, okay, on which link we can send via the routing table, we can figure out. But we also need an ARP cache for this router. So you can see, for example, here, show ARP in this router 0. So what is there? 10.1.1. This, its MAC address. This is the interface on which my MAC address is. This one's 10.1.1.2. This guy pinged me through this. And its interface is also the same interface. What is the hardware address? This hardware is A400, I guess. A400. See, the hardware address is also mentioned. And how can it be reached? By this gigabit 000 interface. Then you have this network. 3.1 is its own interface, and 3.254 is this guy's interface. Similarly, you can see config show ARP. So it knows, because of this ARP and ICMP process, this guy can be reached through this interface. And this guy's hardware address or MAC address is this. $2730. Again, this interface 3.1, it knows it's directly connected, and 3.24 or 254 is its own interface. So this is how things happen. There are ERP tables, ERP cache that has to be filled up in the PCs. Similarly, the ARP caches has to be filled up in the routers, and the routing table also has to be configured properly to reach from one network to the other network. For example, we can now try pinging from here to here, let's say. Let's try pinging from uh, here. We'll go to simulation mode and try pinging from one end to the other. And the ARP caches will be updated. I hope so, at least. You can check out on your own. So its ARP is obviously this one. So ping 10 point, what is the network? This is 2 and 3, 1.1.3. And let's do it 3 times again. Where to send, nobody knows. MAC address is not there. So ARP has to be initiated. It responds back. This router responds back. It's its default gateway. It will respond back with its own MAC address. So now it knows that if I have to send to this guy, I must use the MAC address of this router, this link specifically. Now by this time, I think ICMP, okay, it floods it, it goes there. Then I guess by this time, ICMP has timed out. Let's see. Let's go to PC3. Oh no, it did not time out because we have already configured the routing table. So it does not know the MAC address. Okay. And it sends again. It's the second time, but request timed out, previous case. Sends again. This is interesting. Because we were pinging, which PC we were pinging 10.1.1.3. Oh, we forgot. Anyhow, so I forgot again. Desktop config fast Ethernet 10.1.1.3 255.255.0. So it should work now. So okay, go to simulation mode. Let's try once again. So go. Routes are already created. Yes. So it responds back. So at least two of the 2 of them will be successful. So let's see. Yes, the first one was timed out because the ARP process was not complete, and so the ICMP process got timed out. But the rest too, once the ARP routers and switches learned, because the switch also has to flood the MAC address table. The routers have to also update the ARP cache and then forward it. So once that is configured, then this ping process is successful. So I'll come back to real time. So this is what happens. This is how a router is able to deliver data to different networks, or routers deliver network. Now you can do some experiments here. So you can bring 2-3 routers like this and create paths. Okay. And then instead of using static routing, you can use dynamic routing and see what paths they take. If suddenly after some time you disconnect or switch off one of the routers, does the routing table change? You know the command how to check the routing table. So let's first change this. Let's first try and remove this IP route, no IP route, okay, and configure instead configure some dynamic routing. But before that, let's see. Show IP route. Yeah, so static route is cancelled. So this is the right time. Let's do router. This is the command. Generally, if you remember, if you are in, let's configure terminal config mode, you have to enter. Then generally you say interface gigabit something and you do something. Okay. For example, what did we do? You can configure IP address also through commands. You can shut interface or switch off interface, or it's called boot up interface. All those things and you can do. But here we are going to use this command router, not the interface. We are updating the router table, routing table. So router rip, this is the command we'll use. And then you will use the command network. What do I have to tell this network? The interesting thing is we just have to uh, say what are the networks it is connected to. You don't have to say that if you have to reach this network, what is the route? That is done in static routing. You just have to specify what are the networks it is connected to, and then these routers will exchange information with one another and find out what has to be done. Okay, so I've removed static routing. So now we'll give network. Already it knows these routes, but we have to configure it. This is the procedure. 10.1.1.0 is a network it is connected to. It is also connected to 10.1.3.0. So we'll end this. WR is a command for write the configuration to save the configuration. So similarly, let's do here. We'll do enable. So we'll do router. Okay. Rip. What is the? It is connected to this network and this network. So let's 10.1.10.1.2.0. Okay. and network 10.1.3.0. These are the two networks they are connected to. Now let's see, has anything happened? We have already removed the static root. You could see, we have already shown show IP root. Now see what happens. It has found out this is router 0. It has found out using RIP algorithm that this network is connected via this. We did not manually do anything. We removed the static route before, if you remember. So the routing table, in fact, you can also see, where is it? Sorry. You can also see it's mentioned R, and R means RIP. You could have also used some other internal routing algorithm. You can find all those commands in the net, how to configure it. But it's a simple way to do it. You could also do it, I think, by GUI here, but it may or may not, means you have to figure out. You have to say. This is the command that is there. You can easily check on the internet. Use the command interface. It's fast. But you could also do by GUI. But other internal routing protocols, you have to use commands. There is no GUI available in packet tracer for them. So now similarly, let's we have done this. So let's see, show IP root. Yeah. So this network you can reach via, oh, the static is already there. Let's remove the static. Where is it? Let's remove the static and then command line interface. The RIP network 3.1.3.0 and these two are so no static root is there. Show IP root. Now the static root is removed, and through RIP it was able to find out that to reach this network it has to use this link, and rest are connected directly or locally. So you can simply again run it. You can check in a real time, or this one. Let's ping from this PC now to this PC. We have not done it. Let's whether it's successful. So ping from this PC to 10.1.2. Let's say 2. Yeah, it's successful all the time. Send for. So if I do 2.3, sorry. So this is what it is. So what you can do is you can add more routers, create more links between these two networks. Okay. And then check out how RIP works. You can also try out other internal routing protocols. Okay. And suddenly you can switch off one of the routers to see how the RIP protocol behaves. Okay, how it updates its routing table and how it is able to deliver packets. So that's all. We'll discuss about the so-called how actually servers and clients get what is called transfer data and access the network, kind of what is called a mini internet we'll do in the next demonstration. Thank you.